In fact, I don't know that I've ever done one exactly like this. I hope it works out. So we have an ellipse. The eccentricity is a 0.8, so that's known as E equals a 0.8, or 4/5. And the vertex is here. Well, keep in mind that we're in polar form, so this is not x and y, this is r and theta. So this is saying when r equals 1, you've got theta is equal to pi over 2. So that means r equals 1. This is 90 degrees, so if you go up here to 1, that's going to be a vertex. So that means that this thing is either going like this, or I guess it could be going like this, hit the vertex and then go around, or it could be going like this, or it could be like this. So one of those possibilities. Now, the other thing to keep in mind is that in general, in polar form, you've got r is equal to E times d, and then it's going to be 1, and it can be either plus or minus, and then it can be either sine or cosine. Right now, I'll just write sine. And sitting in front of that's E, and then sine of theta. So what we could do is just say, I'm going to use E, I'm going to use 1 plus sine of theta, and see what this shape looks like. So, in polar form, I'm going to start with E is a 0.8 or a 4/5, and I'll try 1 plus the E and then sine of theta, and then see if that goes through that point. So 0.8 divided by 1 plus 0.8 sine of theta, lots of parentheses, the window from first of all, the theta is 0 to 2 pi, and then from -5, well, that goes to a height of 1. Yeah, maybe -5 to 5, -5 to 5. And then, so it's going down, it's not quite hitting right here at this point. So maybe we could try adjusting by using cosine instead. Well, then that one's going sideways, and again, it's not hitting that, and also this would be the vertex over here. So what if I used subtraction? Well, then that looks like it is hitting at that point, but that's not a vertex, that's just sort of on the side of the ellipse. That's not a vertex here, a vertex here. Notice when I'm using the cosine, the vertices are on the left and the right. They're not up and down, and that's not going to be correct. So y equals, so go back to sine. So as I said before, it could be going like this, or it could be going like this. The problem with this one is it's so far away from this point, I would have to have this shifted up by like 1.5 points in order for that to be a vertex. So my next idea is going to be, okay, if this is my function, this is giving me values to plug in. So what I did at first is I just said, let's pretend d is equal to 1. And it didn't quite work out, so d is not equal to 1. We have to find out what d is. And this given information means just plug in pi over 2, plug in a 1, and then we should be able to solve for d. R is a 1. Sine of pi over 2. Let's see, sine of pi over 2, sine starts at the x-axis, goes up, so sine of pi over 2 is a 1. That means that we have 1 equals, this would be a 1 plus a 0.8. Then do some fancy algebra. And we've got a 1.8 divided by a 0.8. So then 1.8 divided by a 0.8 is 9/4. D is equal to 9/4. Alright, so if we put that back here, this is going to be a 4/5 times a 9/4. So R is equal to a 4/5 times a 9/4. It's going to be 9/5. And then 1 plus now I don't remember, was that 1 plus or was it 1 minus? Let's see. It was 1 minus. Or was that the one, that's the one that's too tall. We need 1 plus. And we need to change this to 9 divided by 5. And then that looks good. So I need to change the y value so I can see the bottom of it. Make sure it's the right shape. That is an ellipse. And if you look at right here, if I plug in pi over 2, if I plug in pi over 2, it should be right there at 1. Yep, there it is. We got it.